Assalamu alaikum, my dear students. Hopefully you are well and safe. Welcome to Higher Mathematics online class. This is Imam Hasan, Senior Teacher, Department of Mathematics, Milestone College. Today we discuss chapter 7, Inverse Trigonometric Functions and Trigonometric Equations. Today we discuss only the MCQ part of this chapter. Hopefully this class will be very helpful for you. So let's start our class. My dear students, today we discuss chapter 7, Inverse Trigonometric Functions and Trigonometric Equations. Today we discuss only the MCQ part of this chapter. In this class, we discuss the most important MCQ questions from this chapter. Now, our first question number 1, domain of sine inverse x is what? We know for x belongs to -1 to +1, the function sine inverse x is exist, and the value of sine inverse x is varies from -π/2 to +π/2. Therefore, the domain of the function sine inverse x is -1 to +1 and the range is -π/2 to +π/2. Now our question is domain of sine inverse x is, that is option C, -1 to +1. Now our next question number 2. What is the range of tan inverse x? We know for any x belongs to R, that is the set of real numbers. So for any real number, the values of the function tan inverse x is varies from -π/2 to +π/2, that is -π/2 to +π/2. Therefore, the domain of the function tan inverse x is R, that is real number, and the range is -π/2 to π/2. So our answer is option A, that is -π/2 to +π/2. Now question number 3, what is the principal solution of f of x equal to sin x? We know the minimum value of sin x is -1 and maximum value is +1. So the principal solution of the function f of x, that is sin x, will be -1 to +1. Therefore, our required answer is option D. Now question number 4, what is the value of cot sin inverse half? For solving this type of problem, we have to draw a right angle triangle. Let triangle ABC is an right angle triangle where angle C is an acute angle theta. Then here sine inverse half. We know sine theta equal to perpendicular by hypotenuse. So perpendicular will be 1 and hypotenuse will be 2. Then by Pythagoras theorem, we have to find the value of BC. Here, by using Pythagoras theorem, we will get BC equal to √3. Now, here cot sine inverse half, we can write this as cot inverse. We know cot theta equal to base by perpendicular. So base is √3, so √3/1. Now cot and cot inverse are opposite function, then we'll get here √3. So our solution is √3, that is option D. Now question number 5, tan inverse 1/3 equal to what? Here tan inverse 1/3, we can write this as half into 2 tan inverse 1/3 equal to half into here 2 tan inverse 1/3. We know a formula, 2 tan inverse x equal to sine inverse 2x by 1 plus x square. By using this formula, we solve this question. By using this formula, here we can write 2 tan inverse x equal to sine inverse 2 into x divided by 1 plus x square, that is 1 plus 1 by 3 whole square. Then half into sine inverse, here we will get 2 by 3 divided by here 1 plus 1 by 9. Then equal to half sine inverse, here 2 by 3, so 2 by 3 divide becomes multiply, then here taken LCM as 9, we will get 9 plus 1, that is 10 by 9, so we have to write 9 by 10. Then half sine inverse, by simple calculation we will get here 3 by 5, so 3 by 5. So our required solution is half sine inverse 3 by 5, that is our option B, half sine inverse 3 by 5. Now question number 6, what is the value of sine tan inverse A by B? For solving this type of problem, we have to draw a right angle triangle. Let triangle ABC is a right angle triangle where angle B equal to right angle, and let angle C is an acute angle theta. Then here tan inverse A by B, we know tan theta equal to perpendicular by base, so we can compare AB as A and the base BC as B. Now here sine tan inverse A by B, we can write this as sine inverse. We know sine theta equal to perpendicular by hypotenuse. Here by using Pythagoras formula, we will get the hypotenuse equal to a square root a square plus b square. So sine inverse perpendicular by hypotenuse, that is a by root a square plus b square. Then sine and sine inverse will be cancelled, then we will get a divided by root a square plus b square. So our required answer is option A, that is a by root a square plus b square. Now question number 7, if sine inverse x equal to 2 theta, then the value of cos 2 theta is what? Now here given sine inverse x equal to 2 theta, then we can write this as x equal to sine 2 theta. Now we draw a right angle triangle. The triangle ABC is a right angle triangle where angle C is an acute angle, that is 2 theta. Then here sine 2 theta equal to x, we know sine theta equal to perpendicular by hypotenuse, so we can compare AB as x and AC as 1. Then by Pythagoras theorem we can find the value of BC. Here the value of BC will be a square root 1 minus x square. Now we have to find the value of cos 2 theta. Therefore cos 2 theta equal to, we know cos 2 theta equal to base by hypotenuse, so it will be a square root 1 minus x square divided by 1. So our required answer is option D, that is a square root 1 minus x square. Now question number 8, what is the value of sine 2 tan inverse x? Here sine 2 tan inverse x equal to sine, here 2 tan inverse x, we know our formula 2 tan inverse x equal to sine inverse 2x by 1 plus x square. Now by using this formula we solve this problem. Here 2 tan inverse x, we can write direct formula sine inverse 2x by 1 plus x square. Then sine and sine inverse will be cancelled, therefore 2x by 1 plus x square. So our required value is 2x by 1 plus x square, that is option D. Now question number 9, if cot inverse P equal to cosec inverse 3 by 2, then P equal to what? Here given cot inverse P equal to cosec inverse 3 by 2 or cot inverse P equal to, we can write cosec inverse 3 by 2 as cot inverse. For finding this value, we have to draw a right angle triangle. Let this is our acute angle theta, then cosec inverse 3 by 2. We know cosec theta equal to hypotenuse by perpendicular. So our hypotenuse will be 3 and perpendicular will be 2. Then using Pythagoras formula, we have to find the base. Here the base will be a square root hypotenuse square, that is 9, minus perpendicular square, that is 2 square equal to 4, then a square root 5. Now cot inverse, we know cot theta equal to base by perpendicular, so cot inverse will be root 5 by 2, so root over 5 by 2. Then here cot inverse P equal to cot inverse root 5 by 2. Therefore we can write P equal to root 5 by 2. So our required answer is option C, that is a square root 5 by 2. Now question number 10, if sin inverse x equal to tan inverse 2 by 3, then what is the value of x? Here given sin inverse x equal to tan inverse 2 by 3. So by using a right angle triangle, let this is our acute angle theta, then we know tan theta equal to perpendicular by base, so we can compare the perpendicular as 2 and the base as 3. Then by using Pythagoras theorem, we have to find the hypotenuse. Here the hypotenuse will be a square root perpendicular square, that is 4, plus base square, that is 9, equal to root 13. Now tan inverse 2 by 3, we can write this one as sine inverse. We know sine theta equal to perpendicular by hypotenuse, so sine inverse 2 by square root 13. Now we can write x equal to 2 by square root 13. So our required answer is option B, that is 2 by square root 13. Now question number 11, what is the value of 2 sec inverse x plus cosec inverse x? Here 2 into, we know sec inverse x plus cosec inverse x equal to pi by 2. By using this formula, we will get pi. Therefore our required answer is option C, that is pi. Now question number 12, what is the value of sec inverse 25 by 24 plus sin inverse 24 by 25? Here we have sec inverse 25 by 24. We can write this as cos inverse 24 by 25. Since we know sec theta equal to 1 by cos theta, so we can write sec inverse 25 by 24 as cos inverse 24 by 25. Then we have plus sin inverse 24 by 25. Now we know a formula, sin inverse theta plus cos inverse theta equal to pi by 2. Therefore we can write this as pi by 2. So our required answer is option C, that is pi by 2. Now question number 13, sin tan inverse half plus cot inverse 3 equal to what? Here we have sin tan inverse half plus cot inverse 3. We can write cot inverse 3 as tan inverse 1 by 3, since we know cot theta equal to 1 by tan theta. So cot inverse 3 can be written as tan inverse 1 by 3. Now here sine tan inverse A plus tan inverse B. We know our formula tan inverse A plus tan inverse B equal to tan inverse A plus B divided by 1 minus A into B. By using this formula, we can write this as tan inverse A plus B, that is half plus 1 by 3 divided by 1 minus AB, that is half into 1 by 3. Now sine tan inverse, by simple calculation we will get here 1 minus 1 by 6, and taking LCM as 6 we will get 3 plus 2. Then here sine tan inverse, here 5 by 6, so 5 by 6 into, here taken LCM 6 we will get 6 minus 1 by 6, that is 5 by 6, so we have to write this as 6 by 5. Then sine tan inverse, by simple calculation we will get 1. Then sine, we know tan inverse 1 equal to pi by 4, so we have to write pi by 4. Now sine pi by 4, that is sine 45 degree equal to 1 by root over 2. So our required answer is option C, that is 1 by root over 2. Now question number 14. Which one is the value of sine square cos inverse 1 by root over 3? Here we have sine square cos inverse 1 by root over 3. We can write this as sine cos inverse 1 by root over 3 whole square equal to sine, here cos inverse 1 by root over 3. By using a right angle triangle, let this is our acute angle theta, then here cos inverse 1 by root over 3, we know cos theta equal to base by hypotenuse, so we can consider the base as 1 and hypotenuse as root over 3. Then by using Pythagoras formula, we can find the value of perpendicular. Here the perpendicular will be a square root hypotenuse square, that is 3, minus base square, that is 1, so root 2. Now cos inverse 1 by root over 3 can be written as sine inverse, we know sine theta equal to perpendicular by hypotenuse, so sine inverse a square root by a square root 3 whole square. Now here sine and sine inverse will be cancelled, so square root 2 by a square root 3 whole square. By squaring this we will get 2 by 3, so our required answer is option C, that is 2 by 3. My dear students, now we discuss our today's last question, question number 15. Here question number 15, what is the value of sec square tan inverse 5 plus tan square sec inverse 2? Here we have sec square tan inverse 5. We know our formula sec square theta equal to 1 plus tan square theta. By using this formula, we can write sec square tan inverse 5 as 1 plus tan square tan inverse 5. Again here plus tan square sec inverse 2. We have a formula tan square theta equal to sec square theta minus 1. By using this formula, we can write tan square this as sec square this minus 1. Now here 1 plus tan square this, so we can write this as tan inverse 5 whole square. Again here plus sec inverse 2 whole square minus 1 equal to, here plus 1 and minus 1 will be cancelled, here tan and tan inverse will be cancelled, so it will be 5 whole square, that is 25, plus here sec and sec inverse will be cancelled, so 2 square equal to 4. So 25 plus 4 equal to 29. So our required answer is option C, that is 29. My dear students, hopefully you all understand today's class. If any problem, take help from your subject teacher. Thank you. Allah Hafiz.